Hello friends, welcome to my YouTube channel Prasad Gunaganti. In this video, I am going to discuss about the topic quadratic equations. Quadratic equations is a simple and easier concept in quantitative part. See, in any competitive exams, we come across these questions on quadratic equations. Especially in banking, we have 5 questions on quadratic equations. So, this concept plays a major role in any competitive exams. See, general form of quadratic equation is ax square plus bx plus c is equals to 0. This is the basic form of quadratic equation. Before going to this topic, I will explain you 3 variables. See, what is constant, what is variable, and what is degree. Okay, constant is nothing but the number which cannot be altered. For example, we can take numbers such as 2, 3, 4 or so on. Those are called as constant numbers. They will not vary in any time. Variables which can be varied. See, variables is nothing but x or y or z. We can assume whatever the number we want in these things. So whatever the x values or y values or z values, whatever we take, we consider those are called as variables. Degree is nothing but order, say highest order in the equation. See, if I take this equation, here the highest order is C. Here we don't have any degree, any order to the constant. Here the degree is 1 to x here and 2 to x square. So here the order is 2. If the order is 2, then we can say that it is a quadratic equation. Quadratic equation, and that equation will have only 2 roots. Okay, if the degree is 2, that equation will be having only 2 roots. If degree is 1, it means we don't have ax square here. If we only have bx plus c, then it will be the highest order will be 1. Then we will say that equation as linear equation. Linear equation, and we have only 1 root for such type of equations. If the order is 3, if the highest order is 3, then we can say that this equation is a cubic equation. Cubic equation, and we have 3 roots for that equation, and so on. If we have 4 as degree, then we can say that that equation is a polynomial equation. Polynomial equation, and that such type of equations will be having 4 roots. 4 roots. Okay, this is what constant, variable and degree is. Let us consider alpha comma beta are roots of a quadratic equation. Then to obtain the equation, x minus alpha into x minus beta is equals to 0. By multiplying these two, we get x square minus of alpha plus beta of x plus alpha beta is equals to 0. Here alpha plus beta are called, minus of alpha plus beta is called as sum of roots. Sum of the roots. Okay, sum of roots is nothing but alpha plus beta, and product of roots is nothing but alpha beta. See, here we have the equation ax square plus bx plus c is equals to 0. If I have compared this equation with this equation, see, ax square plus bx plus c is equals to 0. Okay, I will divide this entire equation with a such that I won't have any any coefficient to x square. So by dividing with a with this entire equation, I get x square plus b by a of x plus c by a is equals to 0. See, now I can compare this equation with this. By comparing, what I get here is minus of alpha plus beta is equals to b by a. Therefore, alpha plus beta is equals to minus b by a. So sum of the roots for this equation is minus b by a, and to obtain alpha beta, we have alpha beta is equals to c by a. So product of roots for this equation is c by a, and sum of roots is for this equation is minus b by a. In bank exams, we don't have the use of sum of the roots and product of the roots. The type of questions they ask in bank exams are, they will be giving us two equations in the form of ax square plus bx plus c is equals to 0, and ay square plus by plus c is equals to 0, and they will ask the relation between these roots of these two equations. So then what we will do is, we will find out the roots for this equation and roots for this equation, and then we compare these two equations and we obtain a relationship between those two roots. Let's see how to find out roots of a quadratic equation. For example, let us consider an equation 5x square plus 3x minus 2 is equals to 0. The basic method to find out the roots for that equation is, we have the equation 5x square plus 3x minus 2 is equals to 0. Now I must divide 3x in terms such that the product must be equals to minus 2 into 5x square into minus 2, that is equals to minus 10x square. So the product must be equals to minus 10x square and sum must be equals to 3x. So I will take 3x is equals to 5x minus 2x. Okay, see 5x minus 2x is equals to 3x, which is a satisfied one, and 5x into minus 2x is equals to minus 10x square, hence my satisfied. So I will take 5x square plus 5x minus 2x minus 2 is equals to 0. Taking 5x as common, x plus 1 minus taking 2 as common, I get x plus 1 is equals to 0. Here x plus 1 and x plus 1 is same. So I will take 5x minus 2 into x plus 1 is equals to 0. So by equating each term to 0, I get 5x minus 2 is equals to 0 and x plus 1 is equals to 0. To obtain the roots for x, I get x is equals to 2 by 5 here and x is equals to minus 1 in this time. So x is equals to 2 by 5, which is equals to x is equals to 0.4 and x is equals to minus 1. These are the two roots of this equation 5x square plus 3x minus 2 is equals to 0. And we have a formula for this, which is minus b plus or minus under root of b square minus 4ac by 2a. Okay, here a is equals to 5, b is equals to 3 and c is equals to minus 2 in this equation. I am comparing this equation to ax square plus bx plus c is equals to 0. Hence I got a is equals to 5, b is equals to 3 and c is equals to minus 2. So the roots are minus 3 plus or minus under root of b square is nothing but 3 square, which is nothing but 9, and minus of 4 into a is 5, so 4 into 5 is 20, and c is minus 2, 20 into minus 2 is minus 40, so we have minus 40 by 2a. 2a is nothing but 2 into 5, that is 10. So what I get here is minus 3 plus or minus under root of 49 by 10. 49 is nothing but 7. Square root of 49 is nothing but 7. So minus 3 plus or minus 7 by 10. If I take plus 7, I get 4 by 10. And if I take minus 7, I get minus 10 by 10. Therefore, I obtain 0.4 and minus 1 as the roots of this equation. This is the formula method. Okay. And the shortcut is, see, we have to follow the shortcut. We must not follow these two methods in any competitive exams, because time is an important factor in competitive exams. See here, the equation is 5x square plus 3x minus 2 is equals to 0. See, now I have to divide 3x such that the sum must be equals to 3x and product must be equals to minus 2 into 5x square, that is minus 10x square. So I will take 3x as 5x comma minus 2x, okay, 5x and minus 2x. Directly I am taking x to the other side and I obtain as 5 and minus 2. So 5x into minus 2x is nothing but minus 10x square and 5x minus 2x is equals to 3x. So hence satisfied. Now simply change the sign of the obtained things. See here I got 5 and minus 2. I am simply reversing the symbols. See, plus 5 is, I am taking plus 5 as minus 5 and minus 2 as plus 2. After changing the symbols, now I have to divide this with x square coefficient. Here x square coefficient is 5. So I am dividing it with 5. Therefore I get minus 5 by 5 is nothing but minus 1 and 2 by 5 is nothing but 0.4. So the roots of the equation is minus 1 comma 0.4. This is how we have to solve in competitive exams. Symbols plays an important role in quadratic equations. See, in comparing the roots, the symbols plays a major role. See, if the equation is in the form of ax square plus bx plus c is equals to 0, here the product of constant and coefficient of x square is positive, okay, positive. Here plus symbol and here plus symbol, hence the product of a and c is positive. Then the roots obtained for that equation will be negative, okay, negative. The roots obtained for this equation will be negative. If the equation is in the form of ax square minus bx plus c is equals to 0, then see, here also in this case also the product of a and c is positive, but here the coefficient of x is negative, so the roots obtained will be positive. Here in this case the coefficient of x is positive, so the roots obtained are negative, and in this case even though the product of a and c is positive, here we obtain the positive roots because the coefficient of x is negative. And in other case, if ax square minus bx minus c is equals to 0, in this type of equation, see here the product is negative, product of a and c is negative, then we get, and the coefficient of x is also negative. In this case we get one root as positive and the other root as negative, okay. But the greater number here, the greater root will be of positive symbol, okay, greater root will be of positive symbol and lesser root will have negative symbol. And if we have the equation as ax square plus bx minus c is equals to 0, in this case also the product of a and c is negative, but the coefficient of x is positive, hence the roots obtained will be of positive and negative root. One root will be positive and the other root will be negative, but the symbol, negative symbol, will have bigger number when compared to the positive number. This is how the symbols of a root are obtained. Now let us discuss about the topic discriminant. What is discriminant? See, we know the formula minus b plus or minus under root of b square minus 4ac by 2a to find out the roots. Here discriminant is nothing but b square minus 4ac. Discriminant is nothing but b square minus 4ac, under root of b square minus 4ac. If this discriminant is lesser than 0, then we can say that the roots are real and distinct. The roots obtained will be real and distinct. if this discriminant is equals to 0, then the roots obtained will be real and equal. Real and equal. If this discriminant is greater than 0, then we can say that those roots are imaginary roots. Imaginary roots. Now I will discuss two important note points here. In comparing the roots, these two note points will help you. See, if the given equation is in the form of ax square plus bx minus c is equals to 0 and ay square minus by minus c is equals to 0. See, if we clearly observe these two equations, the product of c and a is negative in both the cases, okay, and the x coefficients and y coefficients have different symbols. In such type of cases, the relationship between the two roots cannot be established. Relation cannot be established. We can directly say that the relationship between those two equations will not be established. There is no need of solving these two equations and finding the roots. Okay, and the other important note point is, if the equations are in the form of ax square minus bx plus c is equals to 0 and ay square plus by plus c is equals to 0. See here, the product of a and c is positive and the coefficients of x and y have different symbol, then here the coefficient of x is negative, so the negative coefficient will be having greater roots when compared to the positive coefficient roots. So directly we can say that here the roots of x is greater than the roots obtained in the second equations. So we have to remain these two note points so that we can save our time. Without solving the equations and without finding out the roots, we can establish the relationship between the roots of these two equations. Now let us discuss some examples. And the first example is, first equation is 72x square plus x minus 1 is equals to 0, and second equation is 63y square minus 25y plus 2 is equals to 0. See, coming to the first equation, this is in the form of ax square plus bx minus c is equals to 0. Then I can say that here I get one positive root and one negative root, and the positive root will be of greater value than the negative root. So see, now I have to take the coefficient of x as 1 and I have to divide that 1 such that the sum should be equals to 1 and product must equals to 72x square. So I will take x as plus 9x minus 8x, so that plus 9x and minus 8x, such that the product will be equals to 72x square and difference will be equals to x. So after taking them, now I have to reverse the symbols. So I get minus 9 plus 8. Okay, keeping aside, now I will go to the second equation. See, the second equation is in the form of ay square minus by plus c is equals to 0. So in this case I get the two roots in the positive roots. Okay, so now I have to divide minus 25 in the form of the product must be equals to 63 y square into 2, that is 126 y square, and the sum should be equals to 25. But without multiplying 63 and 2, I will take 63 as 7 and 9 and 2 as 2. We cannot divide 2. Okay, by simply see, 9 into 2 is 18, 18 plus 7 is equals to 25. So I will take the roots Now I will take minus 18 minus 18, see 18 plus 7 is equals to 25, but I have to get minus 25, so I will take minus 18 minus 7. So minus 18 into minus 7 is equals to 126y square, and minus 18 plus minus 7 is equals to minus 25y. So both the conditions are satisfied. So I will take minus 18 and minus 7. Now I have to reverse the symbols, so I get plus 18 and plus 7. See, both the roots are positive. Here one root is positive and the other root is negative. Now I have to divide these two with 72 and these two with 63, but in both the cases I have 9 as common multiple, so I will take that 9 aside and divide it with 8. See, if I take 9, divide 72 with 9, I get 8, so I will divide it with 8, because 9 is the common factor between 72 and 63. So I am taking 9, dividing these two equations by 9, so I will be remaining it with 8x square and this with 7y square. So I am dividing it with 8 and this with 7. So what I get here is minus 9 by 8 is nothing but minus 1 point something, and plus 8 by 8 is nothing but plus 1, and here 18 by 7 is nothing but 2 point something, and 7 by 7 is 1. See, it is minus symbol, so no need of comparing it with these two, because these two are greater. Directly we can say that because these are positive terms and this is negative term. Taking plus 1, see here we have 1 plus 1 and 2 point something. So 2 point something is greater than 1 and 1 is equals to 1. So I can say that y, the roots of second equation, is greater than or equals to, because here 1 is equals to 1. So the roots of y are greater than or equals to the roots of x. That is the relation established. Coming to the second example, the equations are 8 by root x plus 9 by root x plus 1 is equals to 7, and second equation is 9 by root y minus 3 by root y is equals to 2. Solving the first equation, we get 8 by root x plus 9 by root x plus 1. Taking the LCM, I have to multiply 8 with root x plus 1. I get 8 root x plus 8. And multiplying 9 with root x, I get 9 root x. Root x into root x plus 1 is equals to x plus root x. So by multiplying x plus root x with 7, I get 7x plus 7 root x. Okay. So by solving this, I got this equation. And now taking left hand side, entire left hand side to the right hand side, I get 7x. Here 8 root x plus 9 root x is 17 root x. Taking 17 root x to the right hand side, I get minus 17 root x. So minus 17 root x plus 7 root x is equals to minus 10 root x plus 8 is equals to 0. Now I have to write minus 10 root x such that it must equals to the product of 8 into 7x, that is 56x, and sum must be equals to minus 10 root x. So I will take minus 14 minus plus 4x. See, minus 14 root x plus 4 root x is equals to, see, minus 14 root x plus 4 root x is equals to minus 10 root x, and product of minus 14 root x into 4 root x is equals to 56x. Hence the two conditions are satisfied here. So these are the roots of root x. Now I have to change the symbol so that I get 14 and minus 4. Now I have to divide it with x coefficient, so I get 14 by 7 and minus 4 by 7. So by cancelling with 7, I get 2 and 4 minus 4 by 7. These are the roots of root x. Now to obtain x roots, by squaring on both sides, I get 4 and 16 by 49. Okay, coming to the second equation, These are the two roots of x. Coming to the second equation, 9 by root y minus 3 by root y is equals to 2. Here the denominators are equal, so directly I can take the relationship between the two numerators. So 9 minus 3 is nothing but 6 and denominator is root y, that is equals to 2. By cancelling with 2 I get 3 by root y, so root y is equals to 3. Squaring on both sides I get y is equals to 9. So comparing the roots, see here numerator is lesser than denominator, so it will be in the form of 0 point something and the other root is 4, but here the root is 9 which is greater than these two, so that I can say that y is greater than x. So the relation between these two equations is y is greater than x. Coming to the third example, for these type of equations, we have to divide this entire equation with the coefficient of x square and this entire equation with coefficient of y square. So taking the first equation, divide the entire equation with the coefficient of x square, that is 2. So by dividing the entire equation I get x square plus 2 plus root 2 by 2 of x plus root 2 is equals to 0. See, now we have to divide this in such a case, in such type that the product must be equals to root 2 and sum should be equals to 2 plus root 2 by 2. So directly we can say that the roots of x are, see here we have 2 and root 2 by 2. Product will be equals to root 2x square and sum will be 2 plus root 2 by 2. Now directly changing the symbols we get our roots for x. Here minus 2 comma minus root 2 by 2 are the roots for this equation. Coming to the second equation, here the coefficient of y square is 1. So dividing the entire equation with 1 we get the same equations. So directly I can take the roots as, see, minus 1 comma minus 3 root 3. By directly changing the symbols of these roots I get 1 comma 3 root 3. So these are the roots of y, second equation, and these are the roots of first equation. By comparing these, directly I can say that these are positive terms and these are negative terms. So obviously positive terms are greater than negative terms, so y, second equation is greater than the roots of second equation, y is greater than the roots of x, so y is greater than x. Fourth example is x square is equals to 25 and second equation is y is equals to root 25. See, x square is equals to 25, therefore x value may be plus 5 or minus 5. See, plus 5 square is also equals to 25 and minus 5 square is also equals to 25. So there is two chances, therefore there are two roots for x, and y is equals to root 25. Root 25 is equals to 5. See, minus 5 can't be happened here because root minus 25 cannot be there. So y is equals to 5, root 25 is equals to 5 here. Therefore we can say that y is greater than or equals to x. 5 is equals to 5 and 5 is greater than minus 5. So directly I can say that y is greater than or equals to x. The other example is, first equation is given as 4 by root x plus 7 by root x is equals to root x, and second equation is y square minus 11 to the power of 5 by 2 by root y is equals to 0. See, first equation the denominators are equal, so directly I can add the numerators. So 4 plus 7 is equals to 11 by root x is equals to root x. So root x into root x is equals to x, that is equals to 11. So x root is obtained, and the second equation is I will take root y as y to the power of 1 by 2. So taking the LCM, I have to multiply y square with y power 1 by 2 minus 11 to the power of 5 by 2 by y power 1 by 2 is equals to 0. Taking y to the power of 1 by 2 to the right hand side, I get 0. Here the bases are same and the powers are 2, therefore I can add the powers. So 2 plus 1 by 2 is equals to 5 by 2. So y power 5 by 2 is minus 11 to the power of 5 by 2 is equals to 0. So y to the power of 5 by 2 is equals to 11 to the power of 5 by 2. Here the powers are equal, so I can take directly y is equals to 11. In this case also I got x is equals to 11, therefore x is equals to y is the relation established from those two equations. Thank you friends for watching my video. If you like this video, then please do like, share and subscribe my YouTube channel Prasad Gunaganti.